Now that we've talked about different types of naming ionic and bimolecular compounds, I want to take a look at acid naming. Now with acids, there's two types. There are binary acids, which have hydrogen attached to a halogen or some other nonmetal, and then oxyacids. And those are where hydrogen is attached to our polyatomic anions that we've seen before. So let's go ahead and first focus on binary acids. With binary acids, we have a hydrogen attached to a nonmetal, and that's going to form our acid, mainly when we put it in solution. In order to start naming these, we're going to take and use hydro as a prefix to indicate that the hydrogen is present. And then we're going to take the name of the anion and change it to ic acid. So let's look at the first one here, HBr. Well, we're going to start with hydro, and then we'll typically have bromide, but we're going to change the IDE ending to ic acid. So we're going to have hydrobromic acid. With the next one, we have HCl. Cl is chloride, so we're going to have hydrochloric acid when we change the IDE ending to ic acid. We'll do the same thing for HI. I is iodide, so we're going to change it to hydroiodic acid. Finally, we have H2S, one of the few examples of a binary acid that has two hydrogens present. H2S. S was sulfide. Well, we're going to change that to ic acid, so we're going to have hydrosulfuric acid. So binary acids are pretty straightforward. We're going to use a hydro prefix and the ic acid ending from the anion present. When we move on to oxyacids, we're having hydrogen bound to an oxyanion to form an acid. Because of this, we're not going to use a prefix. So we don't indicate anything else other than just changing the oxyanion ending in order to say it's an acid. And we have two ways of doing this. If we have an ATE ending, we're going to change it to IC acid. If we have an ITE ending, we're going to change it to OUS acid. So we're going to have a bunch of different species here. If you remember back to when we looked at the polyatomic anions, we had a lot there that were ATE or ITE endings. So here we're going to have a lot of acids that either have an IC or an OUS ending, and that's going to determine how many oxygens are present on the particular molecule. So since we looked at the naming rules for oxyacids, let's just go ahead and look at a bunch of examples here. If I have HNO3, I have nitric acid. If I have HNO2, I have nitrous acid. H3PO4 is going to be phosphoric acid. H3PO3 is going to be phosphorus acid. H2SO4 is going to be sulfuric acid. H2SO3, sulfurous acid. You're going to notice though that in all these, all we did was change the ATE or the ITE ending. Now, when we have the halogens present, the oxyanions of the halogens, we have to remember that in those particular cases, we did have prefixes. So those prefixes are going to remain unchanged. So if I have HClO4, we're going to recall that ClO4 minus was perchlorate. So now we're going to just change the ATE ending to IC and add the word acid. So we're going to have HCl4 minus being perchloric acid. HCl3 is going to be chloric acid. HClO2, chlorous acid. HClO, hypochlorous acid. Last but not least, we have one of the only acids that you're very rarely going to see, H2CO3, carbonic acid. Carbonic acid is important because it's how our bodies actually transfer CO2 from our cells to our lungs. So carbonic acid is a very important acid, but it usually doesn't stay around a lot. It likes to decompose readily, and we'll talk about that a little bit more in depth when we get into reaction types. So since those are the basic ways of naming acids, binary acids and oxyacids, and I gave you a bunch of examples, go ahead and practice the 3 that are on this last slide. Remember, pause the slide and write these down, and then you're going to be able to work on these in class, and we'll work through everything in a little bit more detail. There isn't a lot of depth to the binary acids and oxyacids. It's just you have to get used to identifying which one has the hydro prefix, and that's always going to be the binary acids. You never add a hydro prefix to any of the oxyacids.